Hello. Okay guys, so this is exercise 4.12, and what we're starting off with is question 8. Please make a note of what questions I did in class so I can fix that up at the end, okay? Now we have a geometric sequence. If we didn't know it, it tells us that it's 1, okay? Okay, so it tells us that it's 1, okay? So it's going to be 1 plus x squared, okay? Plus dot, 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 dot. Now, what we can tell right away is that a equals 1. We can tell that the r value is what, guys? X. And then it goes sum of infinity. I'll just find my sum of infinity formula, which is a over 1 minus r. And what this means is when I add them all together, they're going to converge towards a number, okay? So the number in question is going to be 1 divided by 1 minus x. And that is it. Yeah, that's it in a nutshell. Okay, so moving on. Sorry, I'll probably do one more.
Number 9 then.
I have number 9 done in the video. I'll do number 7, okay? Now, number 7, guys. 7 is basically, so we're doing 7 and 8 so far. So 7 is, we can see that it's changing sign every time. So if I ever want to find out the r value, remember it's just simply t2 divided by t1, which is minus 0.1 divided by 0.2. And what that gets me is an r value of minus a half. The a value is 0.2. And all I have to do in my calculator is this. Use my s infinity formula once again. Put my a value as 0.2. Divided by 1 minus my r value. And if somebody could look up 0.2 divided by 1.5, that'd be great. 0.2 divided by 1.5, anybody?
2 over 15.
2 over? 15. Guys, that's it. That's questions 1 to 9. They're that easy. With this one, it's only going to have letters in it. It's no big deal. Can I move on? Okay. Very good. Alright. Now, what we're going to do next, guys, is we're going to evaluate a third to the power of n. Now, some people get a bit confused with the language on these ones, okay? So, oh, that doesn't work. Okay, so some people get a bit confused with the language on this. The big E means basically it's a series. So I know it's a series. I know that the first term is u0. Like term 1 is inputting n equals 0. So t1, your first term, is using n equals 0 because of this value down here. I know that the n value is going to be u equals infinity because I know this number up here. So I automatically know it's the sum of an infinite series. The formula that comes beside the bracket is basically, it's the formula for any number you want. Okay? So let me start off, right? u0 is a third to the power of 0, which is 1. u1 is a third to the power of 1, which is a third. u2 is a third to the power of 2, which is a ninth. Can anybody tell me the r value?
1 over 3.
The r value is 1 over 3. The a value?
1.
A value is 1, r value is a third. So it's just a fancy way of asking you questions 1 to 9. Okay?
Sure.
Yes?
What's the reason that you're using u instead of t?
Just because I didn't want to confuse you with, you know, you're so used to t starting off at t1. I wanted to just show you that, like, technically speaking, t1 is u0. You know, because the first term is by definition of this particular question starting off when you replace n with 0. Okay? And the second term is technically u1, so I just decide to use u when I get n equals 0, just to differentiate the two so we don't get in trouble. Okay? So then what we do is S0 equals a over 1 minus r, and what we have here is 1 divided by 1 minus a third, 1 divided by 2 thirds, 3 over 2. Okay, 3 over 2. Any questions on that one? Not really too bad at all. Okay. We'll move on. Okay. Now. Okay. Moving on. Okay, in questions 12 to 17, the recurrent decimal, show the recurrent decimal in the form a plus b. Now, I was asked to do question 15, wasn't it? That's the one I haven't got done. So, question 15. Now guys, in question 15, what a recurrent decimal means is this. 0.2, and see the way it has the 7 only on, see the way it has the dot only on the 7. That means 7, 7, 7, 7, 7. I will also explain that in question 14 at the same time. 0.72 means 72, 72, 72, 72. So there is a difference between 1 dots and 2 dots. Okay? Now that we've done this, I want you to look at this, alright? 0.2 is the first one. This is 700ths, isn't it? Do you agree with that? The next one after that is 7 thousandths, then it's 7 10 thousandths, and it goes on till infinity. Now, if we isolate this part here, what type of sequence is that? Or series even? It's an infinite geometric series. Okay? And the infinite geometric series is a equals 7 over 100, and then r equals 1 over 10. Then just put in s infinity. We're going to find out what all of this in the red box is added together. It's going to be a over 1 minus r, and then it's going to be 7 over 100. And if somebody be quick with this on the calculator, that'd be brilliant. Plus 7 hundredths divided by 9 tenths would be excellent. 7 hundredths divided by 9 tenths.
63 over 1,000.
63 over
1,000.
1,000, okay. Now guys, this 63 over 1,000, okay? Technically speaking, it represents everything in here. So what I have to do next is I want you to add on 0.2 to that. So what's a 63 over? What did we say was 63 over 1,000? And that represents everything that was in that red box. Add it to 0.2 and what you get?
263
263
over 1,000.
Really?
No,
I think we made a calculator error.
I got 0.777776. I got 7 over 90.
You got 7 over 90 for this part here?
Yeah.
Okay, I think you're right. 7 over 90. Lads, sorry guys, that's 7 over 90. Add 7 over 90 to 0.2. What you get?
5 over 18.
5 over 18. Now here's what I want you to do. Put 5 over 18 into your calculator and press the change button. So, 5 over 18 into the calculator. And look, 0.27 with the dot on top. Is that what we started off with? 77777. What's the last one then? 8? Just rounds it up. Okay, and that's what we're looking for there. 0.27.
Yeah, brother.
Okay, lads, moving on. Any questions, sister? No. Okay, guys, now, there is one thing I'll clear up with you now, okay? So, before we do the homework, okay? This one here, the 0.72 72 is slightly more difficult. This 72, what does that represent? 72 over 100. What does this 72 represent? Over 10,000.
110.
You see the way we said, see the way that's 7 tenths. That's 7 tenths, that's 2 hundredths. We decided to use hundreds. You always use the second one. So this is 1 thousandths, this is 10 thousandths. 72 10 thousandths. This is 100 thousandths, this is millions. So it's going to be 72 over a million. Okay? And now you do the same thing. A full series is set A equals 72 over 100 and R equals, what's the difference between 100 divided by that? It's 1 over 100. If you really weren't sure about that, you could always just do T2 divided by T1 and you could just enter like the full thing in and then just divide by 72 over 100 and you'd find that that'd give you your 1 over 100 as well. Is that right? And then just put into the sum of infinity series. Okay guys, moving on. This is a geometric series. Find two values for x, the common ratio and the sum of infinity. We've done these types before, haven't we?
Yeah.
So what can anybody recommend me what to do?
T1 or T2 over T1 equals.
Sorry? So it's going to be 24. Yeah, you're right. T2 over T1 equals
T3 over T2.
T3 over T2. I think you guys be confident in this one at this stage, would you?
Yeah.
You've done enough of them. Cross multiply, find out the x value. Once you find out the x value, then you can find out the a value and the r value. I think it's easy enough. Actually, we'll do another one. 25 actually looks a bit nicer. Okay guys, factorize 1 minus r squared. How do you factorize 1 minus r squared? Can we remember?
Two squares.
Difference of 2 squares. 1 plus r, 1 minus r, or the opposite way around. Now they say this here is a geometric an infinite geometric series with, what's the significance of this part here? The r less than 1. It means that it's a convergent series, doesn't it? Because the r value is less than 1. It means it's getting smaller every time. It's a fraction. R is a fraction. The sum of infinity is 8. And the sum of infinity of the even terms, is 2. Find the value of the common ratio. Now, that's an interesting one. Okay? It's pretty interesting. So guys, look at this. Let's start off, even if you can't get the full question in the test, how would you pick up some marks? Sum infinity equals 8. Just put a into 1 minus r equals 8. Cross multiply. Like, this is where we go wrong sometimes. We just leave that blank just because we know we can't get the full answer out. But if you got that, you're on the board. Okay? Now, the even terms. Okay, well, what I'm going to do here, guys, haven't seen this question before, have to think about it. T2, T4, so T2 is AR, T4 is AR cubed. What do you think the next one is? AR5. AR5, and then it's AR, all the odd numbers, isn't it? 7, 9, 11, 13, 15. Okay? Now, all of a sudden, I have a new type of series. What's technically the r value in this one? What am I multiplying by each time? R squared. So this is interesting now, okay? So now I have a new one. It's going a into... Now, what's our a value? Technically, guys, technically it's like this. The s, it's two things. It's two boxes. The A and the R, it doesn't have to be A and R. It's just whatever represents A and R. So in this question, what represents A?
AR.
AR. Because AR is the first term. The first term goes into this box. What you multiply each term by goes into the second box. And what you multiply each term by?
R squared.
R squared. And we know that this equals 2. Okay?
No, sir, that's odd numbers, isn't it? No. Even numbers is
No, even terms is 2. And the even terms of this sequence are T2 and T4. And I put them down as AR, AR cubed, AR5, and I treat that as its own series. Okay?
The even terms are to the power of odd numbers.
Yeah, the even terms are to the power of odd numbers because just the way it's set up. Might not always be that way. It's to each individual question. It has to do the same thing. Okay, now, guys, what we're doing next is we're going to cross multiply this up, and we're going to get AR equals 2 minus 2R squared. Can anybody tell me how to finish this off?
Bring it to the left.
Replace with A. So 8. So it's going to be 8 minus 8R for A, multiplied by R, which is 8 minus 8R squared equals 2 minus 2R squared. Going to bring everything to one side.
That'll be 8R. It's not 8R minus 8R squared.
It is 8R. Yep, thank you. And then we move it all to one side. So we're going to get 0 equals 6R squared minus 8R plus 2. Okay, once we've done that, what we're going to do next is we're going to do the going to divide by 2, I think. I might as well divide by 2 and then make it an easier type of quadratic. So you're going to get 3R squared minus 4R plus 1. Reference number of what, guys? 3. Break up 3 into minus 3 minus 1. So then it's going to be 3R squared minus 3R minus 1R plus 1 equals 0. 3R into R minus 1 minus bracket 1 into R minus 1. 3R minus 1. R minus 1 equals 0. R equals 1. Can R be 1?
Is that not R plus 1? So
That's R is less than 1.
Sorry?
R is less than 1.
Okay, and also, if R equals 1, it's not a geometric sequence. It stays the same. And then,
You're not multiplying that minus 1 divided by minus 1.
oh yeah, minus 1 by R is minus 1R. Minus 1 by minus 1 is plus 1.
There's minus 1 in brackets beneath.
Which one?
So you don't need this bracket minus 1 brackets beneath that.
Oh, like R minus 1 equals 0, and then bring the R up to your side and get R equals 1.
Yeah, but you don't need it. It should not be plus 1 in the bracket beneath it.
This one?
Yeah.
No, this is minus 1.
Yeah, you're multiplying minus 1 by minus 1.
Yeah, but he's not multiplying.
I'm not multiplying, I'm just factorising it back in. Okay, it's alright. And then 3R minus 1 equals 0, 3R equals 1, R equals a third. I'm pretty sure R equals a third for that one. Okay guys, I think that was the last one. Yeah, what questions did I do there today? So, you can, okay.